Hey there, pre-AP. I know we didn't get to finish our water potential problem today, so let's try to get some things cleared up so that you can be able to try cell number 2 for homework tonight. So what we're going to do is, remember, this is cell number 1. We have side A and we have side B. Now, for each of these sides, we have already calculated the number of stars. Remember that stars, they are solute. Solute means that this is either something like salt or sugar. If you want to make yourself this note, solutes are solid particles. That's what that means. They are solid particles. Solute, solid, S-O-L, S-O-L. Super easy to remember. So let's look. We said today that in side A that we had 13 stars. That means that that represents a percent. It represents the percent of solute on that side. So it's 13% solute on side A. And then on side B, we calculated that it was 21 stars. That represents 21% solute. But remember, this is a problem dealing with osmosis. So we want to know where water's going to go, basically. And if we look at the letters that we have to answer, we have an A, a B, a C, a D, and an E. And let's start with the first letter, A. So if you look at your equation that they give you at the beginning that you wrote down, you are trying to find Triton T, water potential. And it says that water potential is Triton S for solute and Triton P for pressure. All you have to do with these two numbers is simply add them. You'll do the same thing on side B. But let's take care of side A first. So let's think about this. You have a negative number and you're adding it to a positive number. So remember from algebra, whenever you add a negative number and a positive number, the bigger number. So think about this as 1 or 0.5, the larger number. Whatever the larger number sign is, that would be the sign that your answer will keep. So remember that 1 is much bigger than 1/2, so that means that our answer has to be negative because 1 is the larger number. And then so add that up in your brain. Okie dokie. That would be negative 0.5. And then we'll do the same thing on side B over here. Which number is larger, 2.5 or 1.0? Good job, it's 2.5. So, because 2.5 is negative, your answer will be negative because it is the larger number. And then if you add these two together, then your answer will be negative 1.5. That's it, simple. All you have to do is plug these numbers down in here. And then do the same for side B. Super easy. All you do is add those two numbers. Awesome. Got A accomplished. Boom. So, let's move on to letter B. Letter B and C are asking, where in the world is my water going to flow? And they ask you to use these symbols. They ask you to use the symbols pointing to the right or to the left, indicating where that water's flowing. Is it going to flow from left to right or right to left? Where's it going to go? Well, we're going to find out. So, if we look at side A as a whole and side B as a whole, we say that side A, this would be considered to be 100% solution. Not solute, but solution. Now you're thinking, Miss Bonner, where did you get the word solution from? We haven't had that. What are you saying? Well, let's explain this. So, put this note on your paper, please. You will need to know this. All a solution is, solution equals your solute, those solid particles, like that salt or sugar, plus your amount of water. Now, each of these are going to be a percent. Your solution, your whole solution, equals 100%. And your solute, again, is going to be a percent, like up here that we've already indicated. And that's going to also be a percent, your water. So, we're going to have to do a little bit more math. So, I'm going to choose a different color real quick. We'll go with red. So, let's look at side A again. This is 100% solution. I want to find out how much water is on this side because I want to know where it's going to flow in just a minute. So all you're going to do is you're going to take your 13% of solute and subtract it from 100% of your solution, because whatever you subtract, what's left over is going to be your percent of H2O. So, go ahead, grab out your calculator, do a little configuring in your head. What you should have left over on side A is 87%. And then, over on side B, you're going to do the exact same thing. You're going to take 100%, because this is a 100% solution on side B as well. Then you're going to subtract 21% from that. That's your solute. And then what's 100 minus 21? That's probably going to be, if you configure correctly, 79% H2O. Alright, so keep those numbers on your paper. I'm going to clear my screen so it's not so messy. Alright, so over here, remember, we had 13% solute, and we had 79% H2O. On side A, whoa, let's back on up there, minor. On side B, we didn't have 13%. We had 21. Glad we caught that. On side A, we had 13% solute. And then we had 87% water. So those numbers are going to be very important for us for letters B and C. Now, water flow, we want to know the direction of it for letter B. So, how we find this out? Look at your two numbers, 87 and 79. Think about that for just a second. Which one is a bigger number? Is 87 the biggest number, or 79 the biggest number? That's right, 87. So, what we do is we are going to draw an arrow from our large number to our small number. Now, while we do this, remember, osmosis is a type of diffusion. And if we think about osmosis and diffusion, those are both types of passive transport. Now, remember your characteristics of passive transport. Think about Mountain Man Steve. Mountain Man Steve's on top of the mountain. He's on his sled. He goes from a what place to a what place? This applies here. This 87, we are considering it to be the higher concentration, the bigger number. This would be the top of the mountain. 79 over here would be your bottom of the mountain, the lower concentration. So water is naturally going to go from a crowded place of 87% to a very not so crowded place over here on side B with 79%. This is like being in a room with a bunch of people and you're packed in there like sardines, you can't breathe, and all you would love to do is just move away from all those people to a nice, not so crowded place where you can breathe. So, whatever arrow that you have drawn on your paper from 87 to 79, you're going to draw that arrow in the same direction on letter B. Letter B done. Let's move on to letter C. So letter C is actually asking us about our solute flow. So you're going to do the same thing. You want to pick out which is the bigger number, 21 or 13. One of them is going to be the high concentration, the big number, and one of them is going to be the smaller concentration. So do the same thing. Draw you an arrow going from big number to little number. You're going to go ahead and copy that arrow down for letter C. It's that simple. Now, letter D and E, they are talking about your solutions. Hypertonic and hypotonic. Think about what your notes say. What do your notes say? What do they say about your cells if they are in a hypotonic solution or a hypertonic solution? Which one swells up like a hippo? Which one of those shrivels up like a raisin? So if you remember think about those hyper Halloween candy kids. That is going to be a shrivelly raisin cell. And think about why it looks like a raisin. Well, all the water's leaving. But if you're hypo over here, remember, you're hypo like a hippo. You're going to be nice, big and round. Because water is going in. And what would eventually happen is this guy would burst over here on hypo. So, we're going to apply hyper and hypertonic to our solutions over here. Think about the direction that your arrows are going. If you're over here on side A, and then your arrow is moving from A to B, well, that's where your water's flowing. It's flowing from side A and filling up side B. So that means that all the water is leaving side A. And if your water's leaving, are you going to look like a shrivelly raisin or hypo like a hippo? All your water is going to be leaving. So you would circle A, side A. All your water's leaving, it's going to shrivel like a raisin. Well, letter E is asking you the opposite of that. Which one's going to look hypo like a hippo over here? It's going to be the side receiving water, which would be side B. It's going to be receiving all this water from side A, and it's going to swell. Alright, so this is water potential. You got this. I believe in you. If you have any questions, I'm going to write my email address down on this slide. My email is, feel free to email me. Just please don't email me at 11 o'clock. I will be asleep, I promise you. I am an old lady at heart. So Janie Minor, Janie Dot Minor, please don't forget the dot. At albertk12.org. Alright, so I hope that was helpful. try cell 2. We'll check it in the morning. Don't forget to check Edmodo also for what videos you need to watch tonight. Read over that outline. And I will see you in the morning.